All right, so the triangle inequality, will somebody let them in, please? Whoops, I need my pen before we can truly start. Sure, would you just put them on my desk right there? Thank you. All right, there's only one theorem that we're going to deal with today, and it is Theorem 5-12. And it has a name, the triangle inequality theorem. And here's what it says, and we'll talk about different situations, what they mean by it. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. That's the only way that you can have three lengths make a triangle. For instance, let's say that I gave you the following base of a triangle. Let's just say it's 10 units, whatever those units might be. I would need 3 more lengths to make a triangle. Could I give you any 3 lengths I wanted to, and you would always be able to create a triangle? No. Not necessarily. What if I gave you the other 2 lengths as 3 units and let's make it a little bigger, 4 units. And I can't even spell units today. There we go. So here's my triangle right here. There's my base. So I have a 3 and a 4. What's that going to do? Are they going to meet? Are they going to meet to make that triangle top at all? No, they're going to fall, and there's going to be a big gap in between them, right? There's no way that if these 2 lengths right here add together to be less than that third side, there's no way you can make a pitch to make that triangle. You can try all you want, but unless you can stretch these, there's no way they're ever going to meet. So they're going to fall flat. Well, what if I change those, and instead of 4, I made that 7, because 7 and 3 add up to 10. What's going to happen now? They're going to meet in the middle and fall flat again, but they're going to be touching this time. But there's no way that with a side length of 7 and 3 that they can even make a pitch to make that point of the triangle. There's no way they're going to fall flat. There's not enough length to make that triangle. So what would I need instead? I either have to change this to something bigger than 3, 4, or this something bigger than 7, 8. So let's choose 8. According to this theorem, any of the 2 sides added together had better be bigger than the third side. So I've got 8 plus 3. Is that bigger than the third side 10?
Yes.
What's 8 plus 3? 11. 11 is bigger than 10. So yes, but all 3 have to work. So the other 2 I could put together would be 3 and 10. They have to be bigger than the third side, in this case 8. What's 3 plus 10?
10.
3 plus 10, 13. Isn't 13 bigger than 8? Yes. And the last 2 that I could put together would be 8 and 10, right? Is that bigger than the third side, 3? What's 8 plus 10? 18. That's bigger than 3, yes. All 3 have to be yes for it to create a triangle. You might have 2 of them that are yes, but if any one of them are no, it doesn't make a triangle. For instance, let's go back and look at what I gave you before. Didn't I give you like 3, 4, and 10? Was that one of the originals? So let's add 3 and 10 together. Is that greater than the third one, 4? Yeah, 3 plus 10 is 13, that's bigger than 4, so that's a yes. But all 3 have to work. What about 4 and 10? Is that bigger than the third side, 3? 14 is greater than 3, so that's yes. But look at the 2 smaller. Is that greater than the third? 7 is not greater than 10. No. That's why this does not make a triangle. If any one of them is no, it won't make a triangle. So typically, in order to prove if you're given 3 lengths of a triangle, I will always look at the 2 smaller and compare them to the bigger, because those are the ones that are going to tell you whether or not it'll make a triangle. So you ready to look at some examples? Any issues with that? Okay. That's pretty much all you're doing. It's not that hard, is it?
No.
Okay. So, I'm going to cause you to think a little bit. Not too much, just a little bit. All right, example 1. So you have to use your knowledge of that theorem to answer some pondering type questions. If Mrs. Murray gave Irma, don't name your child Irma. Why? Because it was my mother-in-law's dog's name. No. Hopefully not, because I don't think Irma the dog can create a triangle, but we'll see. She was a poodle. Poodles are smart, but I don't think they're that smart. All right, so Mrs. Murray gave Irma 4 pieces of copper tubing. What is copper tubing? Stuff for pipes. What kind of pipes?
Electrical.
Not electrical.
Not electrical.
Plumbing. Yes, your water runs through, well, not all of your water, but like your kitchen water has to be copper. I don't know why. I'm not technical about this. Some of your plumbing is plastic. Used to all be copper tubing, but neither here nor there. We have 4 pieces of copper tubing measuring 6 meters, 7 meters, 9 meters, and 16 meters. Your job is to determine how many different triangles could Irma make? You can only obviously use 3 out of the 4 pieces. You cannot weld 2 of the pieces together to make one whole piece. So you can only use 3 out of the 4. So I want you to talk to somebody next to you without getting out of your chair, somebody or buddies next to you, to come up with how many different triangles Irma can make with those 4 lengths. And make sure that you write them down and test them. So talk amongst yourselves. Let's go.
How many things?
Everybody needs to talk to somebody.
I'm guessing 1. You can only make 1 triangle. 69 and 7. You can't even make that triangle. It's 9 and 7.
We'll see what they say.
And there's no triangle. That's a trick question.
No, it's not a trick question.
Why? You can't.
Oh, by the way, let's say that you chose, I don't know, 7, 9, and 16 as your 3 lengths. 7, 9, and 16, 9, 7, and 16, 16, 7, and 9, those are all 3 the same triangle, right? So don't think that those are 3 different triangles. Just come up with, that would be one combination, right? So bear that in mind. Can you use what?
I'm doing the side.
No, you can't use the side twice because you only have 1 that's a 6.
If it equals, if 2,
1 that's a 9 and 1 that's a 16.
if you add 2 together and it equals a side, does that count?
No, you can't put two together.
There's only one.
What if it's equal and largest?
You can't do anything without it.
Only 16.
All right, stop. Stop. Okay, let me hit the lights. How many triangles did you come up with?
One.
I said 2.
Two. I have one. I have two. All right, so let's write down the combinations and test them to see who's right and who's wrong. All right, so somebody raise your hand, give me one combination.
6, 7,
Well,
9.
raise your hand. Mr. Usher.
6, 7, 9.
6, 7, and 9. I will always write them from smallest to largest on purpose because I don't want to do all three tests because I know it's the two smaller that are going to add to be bigger than the larger. So does 6 plus 7, is that greater than 9?
Yes.
What's 6 plus 7? 13 is greater than 9, that's true. So yes, 6, 7, and 9 is a possible combination that Irma could use for her triangle. What's another one? 16, 7, and 9. So I'm going to put them in order from smallest to largest. 7, 9, and 16. So we want to add those two, make sure that they're bigger. What's 7 plus 9? Is 16 greater than 16? No. So we can't use that combination. Anything else? What was your other one, Eric? What was your other one? You said you had two. Okay. There's only one triangle that you can make out of those four. All right. Example 2.
What do I do?
Example 2 can be easy if you learn, I'm totally losing my pen, if you learn how to solve this one. Whoops, it's 2. Look, it looks like a kindergartner wrote that. Sorry. All right, so example 2. The lengths of two sides of a triangle are 8 and 13. So I'm not telling you the third length. So your task would be, should you choose to do it, what are the possible lengths of the third side? We want to come up with all the possible lengths. Not just one, not just two, but all of the possibilities that you could have given 8 and 13 are two of the three sides. Now let's brainstorm what we would know about our triangle. What could 8 and 13 be on the triangle regarding the sides? Could they be the biggest sides? Could they be the smallest sides? What could they be?
Anything.
Could they be the two smallest sides? If they're the two smallest sides, wouldn't we have something else, one side that's bigger than 8 or 13, right? Okay. They could be the two largest sides, couldn't they? Which would tell us that we would have a side, the third side would be less than 8, right? Could this be the smallest and not the largest? So we could have a side length that's between 8 and 13. So we have a couple of places that we could look. Here's the easiest way to do this particular problem. If those two were the smallest sides, what would you do to figure out if the third side would work or not? Wouldn't you add them together? What do they add up to? 21. So would the third side have to be bigger than 21? Right? So the very first thing you're going to do is add the two sides together. Because we're actually going to come up with a range of values that our third side could be. So if I add the two sides together, I have 8 plus 13 is equal, we said 21. Right? Okay. Then, here's what I want you to do. I want you to subtract the two sides. Now, if I subtract 8 minus 13, what's going to happen? Don't you get a negative 5? Could I have a negative length to the side of a triangle? No. So when you subtract, you want to make sure you have an absolute value or a positive number. So I would always subtract the smaller from the larger. So you need to do 13 minus 8, and what do you get? 5. So what I want you to do is take these two numbers that you got, one from adding the two sides together, one from subtracting the two sides together. Put them in order from smallest to largest. So I've got 5 here and 21 here. We have to figure out, this is going to help us with our range. We need to look at values that are less than 5, values between 5 and 21, and values greater than 21 to see what our side length could be. So you choose a side length that would be less than 5. 4. All right, 4 is less than 5, right? So if we had 4, 8, and 13, wouldn't 4 and 8 be the smallest sides? So what's 4 plus 8? 12. Is 12 greater than 13? No. So would any side smaller than 5 work? No. So we know that we can't have a number less than 5, right? Choose a number in between 5 and 21. 6, 7, 10, whatever, right? Any number you choose, so let's take 6. 6 and 8 would be the smaller, right? So what's 6 plus 8? 14. Is 14 bigger than 13? Yes. Well, let's choose a number that 6 and 8, let's choose a number where 13 is not the biggest. So is there a number between 5 and 21 where 13 is not the biggest? 18. So if I had 8, 13, and 18, okay, wouldn't 8 and 13 be the smaller? What's 8 plus 13? Is 21 bigger than 18? Yeah. So do you think any number in between 5 and 21 will work? Yes. All right. What about, so far this is a no. This is a yes. Choose a number bigger than 21. What number? 22. You guys are such exploring people. All right, 22. So if it's 22, no matter what number I choose greater than 21, won't it be the biggest number? So what's 8 plus 13? 21. Is 21 bigger than 22? No. Will any number that I choose bigger than 21 create a number that's less than that 21? No. So there's no way any number to the right of 21 would work. So where do you think our answer is going to lie? In between the 5 and the 21. Could we include 5 and 21? What if our side length was 5? What's 5 plus 13? 13. Is 13 bigger than 13? No. What if it were 21? Remember what 8 and 13 added up to? 21. Remember, that's how we got our answers of 5 and 21. We added them and subtracted them. And that's what you're going to do to get that range of values. So how do you write your answer? You could write it 2 different ways. You could let your middle side be the variable x or a or s or whatever you want it to be. And you could replace, in between here, put an x, note in your notes that this represents the third side. And then put inequality signs in here. This is called a sandwiched inequality because your variable, your third side, is in between those two numbers. And remember, if you read a sandwiched inequality, you have to read it inside out. So if I read just this half of it, you have to read it backwards, don't you? X is greater than 5. Isn't that what we said it had to be? And X is less than 21. If you were uncomfortable writing your answer this way, use your words. The other way you could write your answer is to do this. The third side must be, and you have to use this word if you're going to write it in words, between 5 and 21. So this is the other way that you could write it, which a lot of you are going to be more comfortable with, to write that in words instead of the inequality. If I said that I'm in between Eric and Brian, am I touching either Eric or Ryan? If I say I'm in between them? No. So when you use the word in between, it implies that the two endpoints are not part of the solution. So therefore, when you say between 5 and 21, 5 and 21 cannot be the third side, but any number in between. Well, why didn't I say from 6 to 20? It could be 6 and 20, but could my side length be 5.1? Yes. So you want to make sure that you leave it to understand that it's not just whole number units, that it could be a fraction or a decimal unit. We could have a side length that's 5.1. Or you could have a side length that's 20.9, right? So this encompasses any possibilities that you can have. All right, so study that. To find your third side length, you add the numbers together, subtract the numbers, and that's your range of values that your third side could be in between. So, to test your knowledge, what if I said that the two side lengths that you currently have would be 7 and 18. You tell me the range of values. Think to yourself. Share that with a person next to you or around you. Okay, what did you get? Well, you can't say 11 and 25. How do you have to say it?
In between 11 and 25.
Okay, here's the two ways. You could say between 11 and 25. Between, you have to use that word between 11 and 25. And where do we get 11 and 25? If you add them together, you get 25. If you subtract them, don't you get 11? Or you could write the inequality, x being your third side, and you have to use, well, if you're going to order them from smallest to largest, you're going to use less than signs. Small, less than. If you ordered it from greatest to smallest, wouldn't you use greater than signs? I wouldn't suggest doing that, but that's your choice. Last example. Example 3. Given a rope, 10 units in length, how many triangles can be made? There are some parameters that you have to follow. Rule number 1. The lengths of the sides, and this is only to help you so you don't have to come up with a zillion different answers. The lengths of the sides must be in whole units. And you must use all of the rope. So you can't have a 1 by 1 by 1 triangle. So what I'm asking you to do is, oops, you didn't tell me you couldn't see it all. I'm asking you to come up with 3 lengths. You have to take that 10 unit rope, whatever the units are, feet, whatever, cut it into 3 pieces. You have to use all of the rope. Can't have anything left over. Those 3 pieces should add up to 10. So you need to come up with, and you can have 2 pieces that are the same. If you could divide 10 evenly by 3, you could have 3 the same, but what did I say about the units? They have to be whole units. So since 10 is not divisible by 3, you can't do that, so it's not going to have an equilateral triangle. But you could do 1, 1, 8. Do those 3 add up to 10? Yes, so then test it. Can you make a triangle out of it? It's the next question. The 2 smaller lengths are 1 and 1, right? Does 1 plus 1, is that greater than 8? No. So this cannot make a triangle. So you can't cut the rope into 1, 1, and 8. So Caitlin, when you hit the lights, and I want you again, you got 2 minutes, chat amongst yourselves. Come up with the lengths. No, it's not impossible. And how many different units?
I got 2 from 4.
No, because 0 doesn't count as a side length because it's nothing.
One of the sides is all,
Right. Because you'd end up with 5 and 5, you can't make a triangle with 2 sides. There is not an endless amount of possibilities. If you could use a decimal, which is why I took that away from you. Because you're right, there would be. With those parameters, it's true. Whole units, yeah, with whole units and using all the row. All right, well, let's talk about this. What possibilities did you come up with?
2.
Okay, let's stop right there. So, stop. What do we get? Did I hear 4, 4, 2? Does 4 plus 4 plus 2 add up to 10?
Yeah.
So I'm going to put them in order from smallest to largest. 2, 4, and 4. So they add up to 10. Does 2 plus 4, is that greater than 4?
Yes.
6 is greater than 4, so this is yes. You could have split the rope into pieces of 2, 4, and 4. That works. Is there more?
Yes. 3, 3.
Erica? 3, 3, and 4. Does 3 plus 3 plus 4 equal 10? Yep. So I'm going to put them in order, again, from smallest to largest. Does 3 plus 3, is that greater than 4? Again, we have 6 is greater than 4, so yes, that's a possibility. Is there another one? Anybody come up with another one? Yes. Which one? Never mind. You sure? 6, 2, 2. Is 6 plus 2 plus 2 equal to 10? Yes. So I'm going to put it in order from smallest to largest. Is 2 plus 2 greater than 6? No. Because we're thinking, I know where you came up with that, you're thinking I have to have 2 that are the same now, right? It just, yeah, it does not have to be isosceles in every instance. In this instance, because the sum of the whole pieces was 10, these are the only possibilities. But let's say that I change the rope length to 11. Then you won't necessarily have an isosceles triangle that makes the statement true. So what if I change it to 11? What would your 3 pieces be? Huh? For 11? 5, oh, let's do it from smallest to largest. 2, 3, and 5. Does that add up? Well, oh, you mean for the 10? Yeah, this would be equal to. So that one won't work for the 10. But what if I change it to 11? So for 11, 2, 4, and 5. So that adds up to 11, right? Is 2 plus 4 greater than 5?
Yeah.
Yeah, so if you had a rope length of 11, see how that's not an isosceles triangle. So I just want you to understand it doesn't have to be an isosceles triangle, but in the original case it was. Any issues, questions, problems, or concerns? Pretty simple? Okay, go grab a textbook. Start working on your assignment.